All right. I believe I'm live. I'll go ahead and get rid of this. Verifying my audio is coming through. Now let me go to YouTube and make sure that I'm actually live. I'm a bit irritated today. You'll figure out why throughout the course of this broadcast, if I am actually live, which I'm figuring out now. I saw a blog post. Let's see. Yeah, I'm live. Fungible tokens on Bitcoin overlays. Beautiful. All right, so I should be able to click on this and give everybody a today. You'll figure out why. Perfect. So I ran across a little this page, right, about.moneybutton.com. These guys were supposed to be the infrastructure for the future of the internet. But unfortunately, I've never heard of Rock Wallet. Electrum SV is a cool project, but it's not the infrastructure for the future of the internet. And Hand Cash is completely centralized. And these are the people that I'm told I should go and use if I don't want to use MoneyButton. I started using MoneyButton about 5 years ago, maybe, when it originally first came out. And eventually was compelled to build my own thing because, well, it's not the infrastructure for the future of the internet like it was supposed to be. The internet needs a way to pay for things directly. So that's why I'm irritated today, is that I saw that post and apparently they're going and doing something new with something or other, and I'm not here to say that's a bad thing. You know, the company got bought, the new owners are going to use their ownership. I'm not going to look very much at chat, I don't think, during this. I might every once in a while, but mainly here to just demo some things that I'd like to show. So, MoneyButton shutting down, right? People built things with it. One of the cool people that built things with it was the MetaNet ICU, which is this group that I'm in. And they built their tokenization with it, and now they have to rebuild it using something else. Because, well, when a centralized system shuts down and when the standard protocols that govern it don't exist, because there were no standard protocols, there was no way to interoperate between wallets. You just had to rely on their one thing, and if that one thing ever goes down, I mean, don't mind this. I'll just leave this here. Right? When you have systems that are defined in ways that other people can't plug into, and when you have one person in charge of setting the rules for how the platform operates, and when those rules are not able to be opened up so that more than one person could provide what's on the other side of the interface, like we see with, for example, all of these standards that have been created on top of BSV, these are a good thing. The reason why this is a good thing, even though nobody reads it, well, some people read it, and actually the people that read it are very valuable. The reason why it's a good thing to have standards for things like a wallet is because when somebody goes away, somebody else can follow the same rules. When Netscape Navigator went away, we had web browsers still. When Internet Explorer went away, we had web browsers still. And hot take, Microsoft Edge, they're going away at some point. I realize they like to say they're a different thing, but guess what? Now they're based on Chromium. So eventually, they're just going to be like Chromium. Anyways, when they go away, I'm still going to be able to access this website. If Google Chrome ever goes away, guess what? Not firefox.com. Well, there we go. Yeah. I can still access this website in Firefox, because even if Google Chrome goes away, it might look a little different. Guess what? Still works. Okay? The point is, people got together and there was a standard. There was never a standard for how to do payments with MoneyButton across different websites and different wallets. Different websites could all plug into MoneyButton, but if MoneyButton ever went away, well, things didn't work well. And that means the people that actually trusted the vision and who weren't up on the technology and who assumed that if MoneyButton ever went away, there would be a replacement, or all those creators that assumed that if Streamanity ever went away, somebody else would be able to pick up and host that content again. Those are the people that get screwed over when there's no standard interface between a wallet and an application, or between a content storage provider and the people who access the content. You need to have a standard way to tokenize assets, and there needs to be multiple wallets to support that same way of doing things. And that way of doing things needs to be well thought through, and it needs to be scalable. So MoneyButton is going away on June 26th. Today, for reference, they gave everybody 2 weeks, is June 11th. And then you won't be able to use the system anymore. And you can get your keys out and you can get your funds, right? But people are going to have to code up a way to actually access those funds, and they don't support they don't provide any tech support for how to actually get your funds out or your tokens out of MoneyButton. So there was a protocol, right? But the trouble is that everybody plugged into something that's now broken. And that's because they plugged into one system and one API. So let's go back to that page. This page here. If you go and look at overlay networks on Bitcoin, this standard here essentially defines how you can track an overlay network on the Bitcoin blockchain. And that overlay network can be used to implement tokenization. And this goes into how you can synchronize data. People don't fully understand this yet, but you can, using this one, not lookup services rather, but 23. Yeah, you can actually synchronize multiple systems together and track state. So what I want to do is implement tokenization of assets. I want to implement fungible tokens on top of an overlay network on Bitcoin. And the reason why I want to do this using open protocols is because if I ever go away, people can still have their tokens. And I think that's important. So Bitcoin uses UTXOs. UTXOs are outputs in Bitcoin transactions that keep track of particular state. So if I create, let's open a text edit. If I create one output and that output has 10 somethings in it, right? So suppose I make an output and it has 10 somethings in it. And then I want to sort of split that output. So now there's 2, right? There was 1, now there's 2, and one of them has 3 and the other one has 7. right? So now there's two outputs, each of which has, right, a different number. Those outputs can be tracked, and that's how you do tokenization. And that's very simple. People think it's more complicated than that. So what we're going to do to implement tokenization of assets on top of an overlay network is, well, we need to start with a topic manager, a way to manage this overlay. What does a topic manager do? Well, a topic manager is going to decide on the admissibility of transactions. So topic managers decide on the admissibility of transactions into overlay networks. So suppose there's a first transaction, right? TX1, which has an output, and that has 10 items in it. You submit transaction 1 to the topic manager. It's accepted. Suppose TX2 spends TX1 and creates two outputs, 3 and 7, right? So TX2 is submitted, and it gets accepted by the topic manager, right? TX3 spends TX2 output 1, which has 3, right? And creates output with 5, okay? TX3 submitted, rejected. Why? Well, because you can't spend 3 and make 5. You only had 3. Sorry. So what happened to that output? TX2 output 1 status, right? Well, how do we know in this output what the token actually represents now? Because it's been spent. Spent by TX3, but it's invalid. Well, that has to be defined by a rule, a protocol rule for the particular tokenization system that we're working in. If a script gets created and then it's successfully unlocked, TX3 successfully unlocked TX2 output 1, but no spend, but was invalid. The script was successfully unlocked, so the protocol rule says tokens no longer exist, right? No one can spend TX3 because it's invalid. Obviously, no one can spend TX2 output 1 either because TX3 already spent it. Okay, so what we're talking about here is now only TX2 output 2 with 7 tokens, with 7 items, is valid. Okay, so that's the behavior we want. I can create things. Let's go ahead and use a little thought experiment here for some valid cases now. We've done the invalid cases, which is right? What happens when someone does a bad thing? tx4 spends tx2 output 2 and creates 2 outputs, one with 5 items and the second one with 2 items. Okay. tx4 submitted, accepted. Okay, so now you can still use tokens. So if you go spend something, obviously, and do it wrong, you're screwed. You lose your tokens. You shouldn't do that. Don't create outputs more than what you had. And these, when you think of how these are going to be framed, we're not talking about actually satoshis here. We're talking about just some signifier, right? A stack element that indicates the amount, but it can be tracked on an overlay. This will make a lot more sense when we actually get into code. I'm being abstract here because this is probably going to be a little bit of a long thing, but by the end of it, we're going to have a tokenization system that uses overlays. PRC22 overlays specifically. And it's going to facilitate tokenization for the type of things that were sort of shut down by money button, only it's going to be done in a way that works and will work forever. So that's kind of the goal here, I think. That's how I'm going to set this up, at least for now. Right, so we got transaction 4, and now we have 2 outputs, right? 2 UTXOs are now in the overlay. One with 5 items, and one with 2 items, right? TX5 spends both UTXOs and creates one output with 7 items. Imagine that, right? TX5 submitted, accepted. We can do that. You can merge and split, right? You can create a transaction that splits into 2 outputs, and you can then spend them. And as long as what you submit spends them properly, it's going to be fine. So using that methodology, we can design an overlay network. Okay? So let's go to the next little section, which is going to be the protocol. Okay? There's going to be an initial mint transaction. Output is going to contain the pub key sub owner. Okay. Op check sig. And then you're going to push sub amount, and you're going to drop. And that's about it. That's going to be your output. Okay. So inputs can spend. Right? And that's how you can transfer tokens. So the token belongs to pub key sub owner, and then checksig makes sure that that public key is signing off on the transfer. And then you're just saying what is the amount of this token that we want to have, right? We don't need identifiers, we don't need anything. We're just using the UTXO structure to define a tokenization system. That's all. So let's go build that. What we need is to check my email on stream, because that's always a good idea. And what we also need is to obviously open up some code. So what I'm going to do is build a new project. Let's call this overlay tokens. Okay. And we'll open the code editor. So we need to have a Babbage identity so that we can use the metanet and have tokens and stuff. And I happen to have one. So that's done. That's all I'll say about that. Now we need a way to mint tokens. So let's go ahead and create one. I happen to have a, I think it's called Simple React app. Yeah. And I'll rename this to, we'll call this front end for now. Okay. So I'll install the dependencies for this Simple React app, which is just a simple React app. And then I want push drop and the Babbage SDK. Okay. I'm installing those dependencies as well. And then I'm going to start this up. I'm just going to open my browser. And then I'm going to have a little front end, which is just a simple React app. Okay. So let's go ahead and I'm also going to want auth right, and that's because I want to submit to a sort of an overlay at some point. We're going to build all this stuff out, but we need to mint tokens, right? So let's actually, no, let's keep it simple, right? I just installed those two things, okay? So in app.js, this is my simple app. Let's just call this token front end. And I want to have the amount. Let's call this token minter for now. Okay, so input type equals number. Value equals tokens on chain. It's going to be something like yeah, that's right. And then we're going to need state variables. So we'll have a little text field. And that's going to be tokens, set tokens. We'll give a 10 as our default, right? So we're going to by default mint 10 tokens. Button on click equals handle mint. Let's go ahead and make that. Let's just say window.alert. Minting that many tokens. All right, so let's figure out what we have in terms of errors here. Looks like Got to close my button tag. I capitalized the B out of habit because I am used to using MUI. But there we go, right? You can enter a number of tokens and you hit the mint button and it says minting 10 tokens. And if I change this to 3,301, now I can mint that many tokens. All right, so what does a mint transaction look like? Let's go ahead and just make the transaction for minting. So I want push drop, and I want to be able to create transactions, right? So we looked at the protocol. We set the protocol up. Where's my text edit? Here, right. So the protocol is, right, pub key sub owner, check sig, push the amount, and then drop. So push drop handles most of that. Create script, or let's just say token script, and push drop.create takes in a few things, right? An object. Let's go look at the docs for push drop.create. And so push drop.create, you can say fields, and you don't really need a key, but you do need protocol ID if you're not using a key. So the fields, let's just say that the field is going to be right, the stringified version of the amount, and that's it. And then the protocol ID, we'll say tokens protocol, and the key ID is going to be 1, just for now, right? So now you can basically issue a thing, and we'll go ahead and window.alert once again, and we'll say token script, token script. So it looks like we got an error. Let's see what the error is. Let's go back. Yeah, we're using await, which means this needs to be async. Story of my life. Forgetting, right? Async when you use await. Okay, let's just say I want to mint 11 tokens. So it says minting 11 tokens. And then what? Do we get an error? Do we get a pop-up? Let's open the Metanet client. Oh, there it is. So it wants to use the tokens protocol. I'll grant. And now it wants to use the tokens protocol again. And what do you know? There's our output script. Okay. So we haven't made a transaction yet, but we have made an output script, which has the minting data in it. So how do you take an output script and put it into a Bitcoin transaction? Well, just const transaction is await create action, and you can say I want to have one output which has this token script, and the satoshis in this output is just going to be like 1,000 or some small number. And then we also need a description for this transaction, and it'll say something like mint tokens. Okay, so I'm just going to switch to console.log because it's easier. So I can console.log that transaction. I'll get rid of this because it's annoying. Okay. So let's mint 11 tokens and actually put them on the blockchain. So there's my little prop. There's a little pop-up. You can see my 1,000 satoshis that I'm putting into this output. And I'll go ahead and mint. And there you have it. There's your transaction. For those of us that like to get the TXID and go on what's on chain while that still exists, which I don't think it will for very long, given that it needs to be aware of every single transaction. There it is, right? So this little output, if we go and look at it, I don't know if it'll show me, but somewhere in here there's 11. There's a number 11. Yeah, there it is, right? And that's basically just the number of, that's the actual thing that's being pushed and then dropped. And I can spend this too. I can redeem this token, use it. Might even be able to use it for issuing discount coupons to a chat service, something like that. Anyways, now we've got a little token minter, pretty rudimentary, could be improved. But of course, the question is, I made this transaction, right? How could I keep track of these, right? And the simple answer would be, well, I could use a basket, right? So I could put this output into a basket, such as the tokens basket, okay? And then when the page loads, I could grab the token out of the basket and show it on the screen, and I could have a little my tokens variable. Right? And I could have a little heading here. I could say my tokens, and then I could say something like my tokens.map x x I, and I could show the list of my tokens on the screen. Right? So, I don't know. There could be a p tag. And then it would be something like json.stringify x. X is an object. So x is an array of objects, or my tokens is an array of objects, and we're showing them to the user, right? And then I could say use effect async, and I could say something like tokens, loaded tokens, get transaction outputs, and I could give the basket, right, the tokens basket, and I could grab this from the SDK. Okay. So now, when I make this, I'm getting a permissions request that says it would like to access the tokens basket. So I'll allow that, sure, right? Now when this loads, I've got my tokens and I've got nothing in the basket right now, but if I make a new one and just say, I don't know, 111, mint, right? I'll go ahead and mint that. Now that's in that basket, and if I refresh the page, right? Oh, am I not? I'm not. I've actually got to put it in there. So, right, there's set my tokens loaded tokens. So the tokens get loaded when the page loads. And we'll look at the docs for the get transaction outputs function. So some rudimentary way to track tokens could be using a basket, right? If you want to just keep track of everything, that's not a bad way to go. Last one there, right? Get transaction outputs, and you provide the basket. So you provide basket. Spendable. I think okay. Type, right? And limit and offset and stuff. So what am I doing wrong here? Let's console. Oh, okay, so number one, that should be an empty array. Console.log, loaded tokens, verify what that is. And then I just want to, demonstrate that, right, there's the array of objects. Okay, so I think this might just be a UI issue, right? I can see my token that I created before. It's in the basket. I can see it's got 1,000 Satoshis in it, right? I could decode that script. I'll do that. Why don't I do that? Yeah, so, right, loaded tokens. So I'm saying JSON.stringify X. I wonder. Oh. I have to return the actual value. And now we can see it, right? That's the actual thing that's here, right? And as part of this, I can also see over here that I have the output script. So if I want to actually make if I want to see the actual amount that I, I have x.output script, right? And I could push drop.decode. So token amount is I can provide the script. And so the point is, if I wanted to track these in a sort of in a basket, without even using anything external, I could. Now there's some disadvantages, and we'll get to that. But let's get the amount. Field sub 0 should be the amount, right? Let's look at the error. Do I not need an await? I think this isn't an async function. So that's a field format needs to be defined. Make sure you set up your typings properly, everybody. Because Ty Everett didn't learn TypeScript when he built this. Anyways, 111, right? And I can go mint another one. I can say 1033, mint the new one. Did I click that? Yes, I did. Okay. And there's the new one, and when I refresh, now there are 2 tokens in the basket. Okay? So that's a way to track tokens internally. But if I want to send these to somebody, it's actually possible to do that, right? But the trouble is that when they receive it, they don't have a way to validate, right? Because there really should be one issuance, right? When I issue a token, it should happen once. If I say there's 1,000 tokens, I mean, there's token systems in which you might want to have multiple issues, but for a simple one, you don't want anybody to just be able to make new tokens willy-nilly like this. Because in this token system, it's like, okay, everybody can just make tokens whenever they want, and that means there's no value. So when I receive something, I want to be able to trace it and make sure that it's valid, and I actually want an overlay network to, track the validity of my tokens according to the protocol that I'm using. And that's the protocol that we started writing about over here, right? So we talked about how you can create new ones, you can have split across different outputs, everything like that. And then, well, you can track tokens that way. You can merge them back. When they do bad things, they're invalid. All that stuff, right? So we have this ability to just create a transaction that adds tokens. And then we have this list of tokens now. But what we want to do is make it more useful. We want a way to check the admissibility of a candidate transaction which is purporting to move tokens and decide whether the outputs from that transaction get to be members of the overlay network that tracks these tokens and that implements the tokenization protocol we want to use. So let's go ahead and do that. In order to do that, we need a topic manager, which is a thing, right? A topic manager, as we defined, right, is something that decides on the admissibility of transactions into an overlay network. So we need to decide on the admissibility of our new transaction. So we go and make a transaction up here, which is first we make the output script for the token. Here we actually make the transaction itself. And then we need to send that transaction to the overlay. Okay. And then the overlay needs to decide about its admissibility. So how do we do that? That means we need a topic manager. And there are some topic managers that are out there. We're going to do a really simple one. So the complicated topic manager that I'm going to copy and then just delete most out of it is called, well, let's think. Do I have a simple one? I'm trying to think. What is the one I just made? Okay. I have one that's really simple. It's called KV Store Topic Manager. So I'll start there and then I'll make a new one. I'll kind of modify it. So git clone KV Store Topic Manager. Okay. So now we have this, and I'm going to rename it to just manager for this simple one. So let's look at it. Let's just go in here. I'll rename this again to manager. And I'll change the actual. I mean, there's a lot here to update, but the one I'll do now is just the name of the thing so I can run it. Okay. Let's go to manager. And we're saying, right, token protocol fields, pub key check sig. And this one has a protected key. This is actually going to be just the amount, right, like we talked about. And then it's going to be a signature from field 0 public key over fields over field 2. So basically you just need, there's a signature. Push drop already does signatures, so you may as well have it. It doesn't really do anything in this case, and it's not necessary. But because push drop already does signatures, we may as well just use it. So I'm modifying our little protocol here. And, I'll refactor this to just say token manager. And here's the core of the function, right? Find admissible outputs. And actually, there is one other parameter. Maybe I should maybe I should look at the UMP one actually. User Management Protocol is another protocol that has a topic manager associated with it. You get previous UTXOs as well as the parse transaction. And so that means you can look at the things that are being spent that were previously there, right? So the parsed transaction is the current transaction that we're dealing with. And our goal is to decide which of the outputs are valid from this transaction. And so we kind of ran through our little scenario over here to begin with to kind of set up the rules, right? First, there was an issuance transaction, a sort of transaction that set up the rules of the game, that kind of made the first 10 tokens that we kind of played around with for the rest of this little demo. So that issuance transaction is essentially always valid. And why don't we decide that that issuance transaction already happened? I mean, I know that, right, this second transaction here with this particular TXID issued 1,033 tokens. That's enough. We don't need more than that. So let's just go ahead and we can look at this transaction and hard code the rules of the overlay to say that if you're the issuance transaction, right, you can look at the output numbers there and actually see which outputs are valid. So let's look at this transaction, and we see that the first output number 0, creates 1,033 tokens. So if, right, very simply, if the TXID is that TXID, then the outputs that are valid are the first output, and that's it. So we're allowing the issuance transaction no matter what. Okay. Now when we submit the issuance transaction to this overlay, it will always be valid, and there will be 1,033 tokens to start with. But let's figure out the other transactions, right? If there are other transactions, what we need to do is look at the previous UTXOs and kind of see how they are used. We want to make sure that the amounts from any previous UTXOs in non-issuance transactions are adding up, right? So the first task is total the tokens being spent by this transaction. So how do you do that? Well, let's look at some code that manipulates or uses previous UTXOs already. And I'm just kind of previous UTXOs has a TXID as well as I think an output script. Previous UTXO sub 0 has a vout. I'm just kind of looking here to see what the format of this data is because I actually don't remember. But essentially the idea is previous UTXOs are things that used to be part of the overlay, right? And now they're being spent by this transaction. That's what we want, right? When you go spend some previous token that you owned, now the spend is part of the overlay. And now it's part of this, this function, so we can see the validity of the new transaction based on what it had consumed. So how that works is, let's go ahead and make a total, and for each UTXO of the previous UTXOs, let's go ahead and, well, we know it's valid because it's already in the overlay. And we'll use the same logic that we had before for map.js to actually decode, right? We just wanted the amount. So let's get the token payload from the previous UTXO, like we're doing here. And this is x dot, so it's going to be UTXO.output script. Okay, and total plus equal and this is a number. Okay. And so basically we're grabbing the total of all the previous UTXOs. Now, how do we know that these are legitimate spends? Well, the answer to that is that the overlay network node already validated the legitimacy of this transaction, including the validity of all of its inputs by evaluating the scripts. And so we know that whatever tokens were unlocked by the inputs of this transaction were legitimately unlocked. And the miners have accepted this transaction as well. So we don't have to worry about any of that. All we have to worry about is here's the amount that we can spend. Okay? So the transaction has previous UTXOs from the overlay that were inputs. And now we validated that. And we have this number, right, this total. And we know that as long as the number of tokens in the outputs are less than that total, then this transaction is valid, meaning that this transaction legitimately moves tokens. And if it goes over, then guess what happens to all these previous UTXOs that have now been spent? Well, they got spent by an invalid transaction, so they're no longer part of the overlay. And the invalid transaction doesn't get to create new outputs. Therefore, the new outputs aren't part of the overlay because the transaction was invalid. It broke the rules. It exceeded the amount, for example. And so, therefore, you know, it's important to make sure your transactions are valid and not spending more than what they should. But what happens now is we're going to go through each of the outputs of this transaction. And, you know, I suppose this logic, right, we're checking to make sure that the transaction is a transaction. Okay, that probably should happen before we do this. I'm going to move all my new logic up a little higher. Well, right, we do this stuff first, right? We make sure that the transaction exists and has inputs and outputs. And then here's where we actually write. We do this. We define the new values. We accept the minting transaction pretty much no matter what. And then now we're down here. Try to decode and validate transaction outputs. Okay? So we're going through each of the transactions. We're trying to decode the output script. And field format I'm going to change to UTF-8 because we're dealing with very simple parameters here. Okay, so we check the signature on the push drop token. And I guess, let's think. If that's UTF-8, if that's buffer, then I can grab, right. So basically we're just making sure that this is a valid push drop token output. And then we're pushing it. But in this case, we do need to do something else. We need to make sure that the so we know that the sort of we need to keep a counter of so we have this total, right, which is it should actually be called like limit or something. Max tokens, right? So that's the maximum number you can create in this transaction, and we need to make sure of total tokens added equals 0. We decode the output, we verify the signature. So the token amount from this output is going to be something like number result dot field sub 0, right? So we're decoding that output again. We got field sub 0, and that's where we are. So we have this number for this particular output, which is how many tokens are in this output. And what we want to do is add that to the total. Total tokens added plus equals output token amount, right? So if the, I suppose we should also make sure that it's you know, more than sort of you know, 0 or 1, right? There should not be a token that is 0 or less than 0. So if the output token amount is less than 1, obviously right, and if the total tokens added is more than the token limit, meaning the total inputs, max tokens is more than max tokens, then we have another error. Transaction output token amounts exceed inputs redeemed. So a transaction cannot have more tokens in its outputs than it has in the inputs. Okay. And we should move this well, in either of these cases, right, the whole transaction is invalid. So actually, we have this try catch here, and it basically says try to decode and verify the signature and whatever, and if anything wrong happens, then just move on to the next output. But actually, if we've exceeded this, right, then right, so I guess we'll say that if this is invalid, if you have less than 1 in your output, then that output is invalid. And then we only need to run this check at the very end to say, after you've gone through all of your outputs, right, then we throw this error and say, right, if you've exceeded that, you've thrown an error, and that error will be caught down here at the very bottom, and no outputs will be admitted to the overlay. Okay. Otherwise, all of the outputs that you've gone through, right, we call this for the output, and then we push it into the transaction. So it's going to be something like outputs push. It's going to be I. Right? So let's go ahead and review this code. What is this doing? This is a function that, given a transaction, will determine which of the outputs from that transaction are admissible into the overlay. So if the transaction's invalid, obviously we have a problem. Okay. If we are the issuing transaction, then it's okay. We'll allow. We'll say that the first output is valid, the 1033. Then we go through each of the inputs and total them, so we know how many tokens we are allowed to spend in the outputs of this transaction, how many tokens are allowed to be created in the outputs. Then we go and build the outputs list, which we're going to return, and we start tracking the total that has been added into the outputs. So for each output, we're going to decode it. If this doesn't work, we're going to jump down and essentially move to the next output. Okay? So we decode it, we verify the signature, then we make sure the output, we actually pull out the amount for the token in that, for the number of tokens in that output. And if that amount is less than 1, then we can't use this output, so it's going to be an invalid output. And then we add the output amount to the total for the transaction, and then we add the output to the list of outputs we're going to admit. At the end of the loop, we make sure that the total we added from all the outputs is not greater than the total we can add from the inputs. And if we do, we throw an error. And then we go through and make sure that there's at least one output admitted from the transaction. Actually, this isn't a requirement, because sometimes in this case you actually want to spend and just get rid of. So I'm going to delete this. Because that just says that there needs to be at least one output that we're letting in. But if I just consume UTXOs and don't actually create an output, then there's no need to have that. So finally, we return the list of outputs. In the case of any errors like the ones we just threw, we say that no outputs get added. Okay? So that's it. That's how you write a topic manager that essentially tracks tokenization in Bitcoin. So for this UTXO subset, we now have a valid way to track sort of tokens. And that means that you can have, 1033, because we hard-coded this transaction up here, right? And then every single thing has to come from a child of this, if you think about it, right? because the only way to initially get tokens into the system is to be this transaction. So any subsequent transaction must essentially spend, right? The next transaction must spend output number 0. Because that's the only way you're going to get anything into this number. Anything into this max tokens number needs to come from previous inputs. And the only previous input that will ever come in here is from that issuance transaction. So that's how you can solve the back to Genesis in an economic way. Is you hard code your Genesis in your overlay, and then you don't have to check every single time. You just have to know that any subsequent thing that comes in has to be from this transaction, because you have this UTXO, which is output number 0 from this transaction, and that's the only thing in the whole overlay, which means that when any transaction comes in, previous UTXOs, which only come from the overlay, need to be a valid spend of that UTXO, or in the future some subsequent valid thing that came from that UTXO. So as long as these rules keep getting applied to every transaction, then there's not really any need to validate anything further, because you know that within this context you have tracked a valid overlay. You've tracked a valid thing on the overlay. All right, let me see if anybody's actually watching, and also if anybody's posted anything insightful in chat. We have one person watching. Maybe that's me. Okay, so yeah, that's where we are with that. I want to proceed. So we've got this topic manager now, and I want to now submit transactions into it, right? I have my transaction here, which I created in my front end for issuing tokens. And I want to be able to actually submit that onto the overlay. So that means I need to deploy my topic manager. Now when you deploy a topic manager onto an overlay node, that is allowing that node to track particular things for that particular topic. And so we also need a way to, you're admitting UTXOs into the topic, and the overlay can be okay with that. But you need a way to get the UTXOs out, right? Because we talked about like this baskets thing and having that internally. We talked about some of the problems, right, that we wanted to implement this protocol. Now we've successfully implemented the protocol for validating tokens in the overlay. So the overlay has a valid subset of these tokens. But users of the overlay want a way to sort of figure out which tokens are theirs and look them up and stuff. And that is another problem. So to do that, you need a UTXO lookup service for your topical overlay that tracks your tokens, so that so that when people want to use your system, they have the ability to access the UTXOs they need. Okay, so that's important. Right now, we're being very simple. And so I'm just thinking the best way of doing this. But essentially, people want to be able to look up by, right? What are all the UTXOs on this overlay? That would be a super simple one. And then also, given a public key, are there any UTXOs that belong to this public key on this overlay? So that way, if I have, right, if I want to go and see, right, what are the UTXOs that belong to me, given that I know my public key, how can I find that? Now, as overlays get more complicated, you're going to want to not reuse public keys. You're not going to want to have a single public key per user. You can use the key ID in the Babbage SDK to derive different public keys for different users, etc. And that is a valid thing to consider, right? You want to make sure that users don't have all of their tokens in one key. And the way to do that properly is to send the tokens peer-to-peer between users and not rely on the overlay as a way to look up token sort of ownership, only as a way to validate token ownership. And that means, is this UTXO on the overlay? And then just check through the lookup service to see that, right? Because I should be able to just send these tokens to my friends and then have my friends be able to use the lookup service to ensure that that UTXO is valid, which is this TXID on the, is this TXID plus vout a member of this overlay, yes or no? So where I'm going with this is we have this lookup service. We have this topic manager. We need a lookup service that can tell me information about whether the particular transactions that I am concerned with are on the overlay or not. And as an additional feature for simplicity, I want to be able to know whether I want to be able to look up all tokens on the overlay and have those returned to me. And I also want to be able to look up by public key. And those two last things are not strictly required if you implement peer-to-peer payments properly, wherein users send each other data directly, such as transactions. The recipient would only need to validate that the UTXO is a member of the overlay without needing to validate anything else. But let's go ahead and just keep building here. So we have the topic manager. I suppose what I need to do right now is I need to actually make some changes to this. I'm going to make sure it's linting properly, for example. Let's see, manager. Make sure I didn't write any errors. Need to install dependencies. Getting a little ahead of myself here. Do I not have the lint installed? Huh. I was pretty sure I had my linter available in pretty much all of these contexts, but I suppose not. Ah, okay, it lints. All right, so that means I've kind of done everything properly. I just want to make sure. So what am I going to call this? Like, I haven't really thought of a name for this project yet. I kind of just started coding. I guess this is very generalizable, right? Like you can track any number of different things with this. So I'll call it tokens topic manager. Manages a Confederacy topic for tokens. I'm being very general here. I'm just trying to get this to a point where I can push it up to Git and actually use it. Tokens topic manager. I guess if anybody ever builds another one that's going to be slightly different, if I'm going to do that, I might as well make it a little bit extensible. So let's think here. I've done package.json properly. Let's go through here. Not much of a README, but if I'm making a generalizable tokens topic manager, so there's a token protocol, there's the amount, those fields 2 through this is 3. And then this is above 3 is drop fields 2 through 3 from the stack. All right, so we give that, and then I also document previous UTXOs. Right. Former members of the overlay spent by this transaction. I think that makes sense. All right, so we've reviewed this code and we kind of know what it does. The one thing I want to do, is there a constructor in this? So this is a class, right? This is a class and there's no constructor. So the constructor I want to put in here is going to have issuance TXID at constructor. I think that's a thing. So I can kind of copy this. But essentially what I want to do is allow people, if I'm going to make this a very generalizable thing, is I want to allow people to use their own like initialize this with their own tokenization base, right, for their own network. They can provide their own TXID, because I kind of just issued my own with 1033, right? So TXID of the transaction whose first output seeds the token with its supply. Simple enough. All right, so you provide in the transaction ID. So this is going to be this dot issuance TXID equals issuance TXID. I think that is like that. All right, so you construct this with an issuance TXID, and there's token manager. I've documented this, and if the TXID is equal to this dot issuance TXID, then the first output is the issuance. Okay, anything else I can annotate here? I think this is pretty self-explanatory code. I mean, we verify the signature. Extract the amount of the token from the output and make sure it's at least 1. Okay. And then we basically add the outputs total to the transactions, add the outputs token amount to the transactions total, right? And append the output to the list. Okay. The transaction is invalid if the outputs total to more than what the inputs unlocked in terms of token amounts. All right, I feel good about this code, and I'm going to push it up. So let's think, npm, right? I want to publish this as token topic manager. So if you can do tokens on an overlay this simply, and if this is like the general case, I didn't realize I was actually coding for the general case here. Basically what happened was I got really upset that I saw the MetaNet ICU had to reissue their stuff on top of, because MoneyButton shut down. But I'm reading through this, tokens topic manager. And I think this is going to be the general case for tokenization on top of overlays for fungible token use cases that are single issuance. So you issue everything and then it's there, and then you can kind of spend it and circulate it around to anybody after that. No, I think this is going to be the general case. So tokens topic manager, no, this looks good. Okay. Anybody watching this live want to steal my npm package name before I publish it? Now's your chance. Let's see. Haha, got it. No one can take my package name. Okay. Tokens topic manager is published. Let's see, git remote, or no, rm tech rf dot git, because I'm lazy, git init dot get remote add origin tokens topic manager. Okay, so we got the topic manager created. Initial commit. I'm going to go make the repo on GitHub. And go ahead and say new repo tokens topic manager. Topic manager for single issuance fungible tokens. Simple enough. Make it public. And send all the code up. So that's up on GitHub now, I think. Yep. Okay. So we got a topic manager. Yeah, now we just need that lookup service to actually track these outputs so that we can verify that, right, so that when a recipient receives a token from a sender, the recipient can check with the overlay network to make sure that the UTXO is legitimate and can see the history if desired. And then also can sort of see a list of everything if you're wanting to do it that way. So let's go ahead and actually do that. So the next thing is going to be lookup service. I want to, I have too many tabs open though. I don't think I need any of that. All right, so here's my front end again. And now we're off to making a lookup service. So I think I copied the KV store last time, so I'll copy that again. Git clone KV store lookup service, and I want to move to what did I call this one? Token lookup service. That'd be cool. Okay. Oh, do I have tokens, plural? I do. But then I have this repo. Uh-oh. Tokens, plural. It is always tokens, plural. Okay, that means that token, uh-oh. So the repo, so I have token lookup service and token topic manager. The token singular topic manager on NPM is called tokens topic manager, and the repo is called tokens topic manager. And that means that in here, all I need to do is rename this to tokens. And this also gets renamed to tokens lookup service. Okay, order is restored. Good. Tokens lookup service rm tackrf.get. Once again, get init dot get remote add origin tokens lookup service. Okay, and we'll go ahead and create that repo now. I won't commit to it quite yet. So tokens lookup service for single issuance fungible tokens. Wow. Once again, I didn't realize this is going to be the general case, but I think it is. So readme tokens lookup service for tokens. All right, simple. Package JSON. Tokens lookup service. And I'm just changing these. All right. Simple. Okay, so let's go ahead and get the migrations. So what does our database schema look like? Okay, we got txid, vout, and then we have the amount. And I guess the owner key. And this is an integer. Okay. And this is called keys. Now it's called tokens. So that's our database migration for our lookup service for the overlay. All right. So the storage engine, let's do the simple things first, right? Node initial implementation, JavaScript class, right? To do create abstract. Okay, so this is basically from a copy of something that so we know the protocol fields because when I looked at so I can copy actually the protocol fields from here. if we need that in the other file too. So I'll just go ahead and replace that. All right. Tokens lookup service, right? And I'll rename this. So I'm looking at the tokens lookup service file, and the topics that I want to look at are, I think actually in this case I want to make the user specify the topics very clearly. So if they don't provide any topics, then no lookup services are provided. So when you construct one of these, you specify which topics you want it to subscribe to for its lookup services. Right, so this function notifies the lookup service when a new output gets added. It has, right, a few things. So we make sure the topic includes there, and then we decode it, right? In this case, field format is buffer. Oh, let's think. Did I treat that? I think I may have found a bug in the topic manager, even though I haven't run it yet. Because when I did field format last time, I decided that field format was going to be UTF-8. But when I verify the signature, alright, so UTF-8, that's okay for that because I'm not verifying it. When I decode this one, I say field format is buffer. But when I want to actually use this, I need to say UTF-8. So there's a little bug. Fixed, so therefore the topic manager fix fields, right? I'll publish that update to npm and push my commits, etc. And then we'll go back to the lookup service. Okay, so this had to fix that bug because that would be problematic. Right, so when an output gets added, we decode the output. We make sure so we get protected key. This is going to be called amount. And UTF-8. That's sub-0, so it's going to be number. So basically we're pulling the amount out just like we did before, right? You decode the output and you pull out the amount. And then we got storage engine.store record, and we're passing in the amount. And I believe we called this owner key in the migrations. Owner key. Yep. So we'll just say owner key is result.locking public key, I believe. And when the output gets deleted, then we delete it. And then when you look up by query, right, this is where we actually do some interesting things. So make sure a query exists, right? If the query dot, what are we actually looking up here? So queries in our case need to be custom, right? How do we want to find records from this, right? So we want to not find by protected key, but find by txid vout if query protected, so if txid and vout right, txid and vout. So you can find by txid and vout. Else if find all, then we can actually just go ahead and find all. And that's a very simple thing. So essentially we're just providing different ways to look up things out of this lookup service, right? And that way we have different options. So that's going to be the lookup service. And now we just need to do the storage engine to make it compatible. So right. So when you have a table prefix on the storage engine, we'll just say tokens lookup. I'm just kind of going through here and modifying as I need to. And I believe this is now amount owner key. And we've already added the migrations. So amount gets stored, owner key gets stored. Delete record, simple. Find by txid vout. UTXOs, txid. UTXOs vout. Whoops, that's not what I want. This is called keys in this case. I'm going to go ahead and actually, wherever this is used, replace it with tokens. So we're just selecting the txid and vout to see if it's here. That's all. And then I believe there's a find all. And that's going to be just without the where. It's usually how that works. So essentially, yeah, you can search through this database and you can find how all these things work. Find this token, or find all tokens. And txid, vout, amount, and owner key are inserted into the database. All right, and we'll verify, yep, tokens are here. Back to the migrations just to verify this is called tokens. Yes, it is. So now we have this little storage engine and this little lookup service that you can use to find your tokens in this generalizable use case. Okay? So what I'll do now is publish onto npm this new thing. Tokens lookup service. let's go ahead and say initial and we'll get that up on GitHub as well, so that when I go over here, all right, we have a lookup service and we have a topic manager. Now what I'm going to do is actually use these inside of a Confederacy instance. So I run a Confederacy instance, and I'd like to open source the instance code at some point. It needs a lot more testing before it can be widely used, among other things, but essentially it is a system for tracking these types of UTXOs. What I'm going to do now is take my lookup service and my sort of topic manager and deploy them onto a node and then run the database migrations, so that when actually people, when we can come back, we can submit transactions to this, and those transactions can be registered on the overlay network. However, it's also getting late where I am, and I'm going to want to do that off camera anyways, because I don't want to reveal how I run my database migrations or migrate keys, things like that. So I'm going to end the stream here, I think. We've made progress on a little front end for issuing tokens, and we've coded up all of the logic for actually tracking tokens and facilitating their lookup and validation. So this is generalizable to any fungible single issuance token on the blockchain. And it's using a Bitcoin overlay network for validation and synchronization of topical UTXO set for the tokens. And yeah, I think it's pretty cool. So I'm going to deploy that, and then the next stream there will be a deployed version of the topic manager and lookup service in operation, and we will implement the rest of the logic for verifying the sort of well, all right, we'll issue some tokens, okay, and then we'll move them around between different parties, and we will be able to have verification from the overlay network that the transfers are legitimate. We'll try some illegitimate transfers and see them not work on the overlay, and then we'll go from there. So I think that'll be generalizable tokenization on top of a Bitcoin overlay network, done in a scalable manner. This was inspired by the recent, once again, money button shutdown of sorts, where they don't allow people to transact any longer. But when users hold the UTXOs associated with their tokens, and when those UTXOs are cross-wallet, and when the exchanges of UTXOs between users can be verified in a peer-to-peer manner, you don't run into such issues. So that's it for me for this stream. Next time, yeah, we'll have some fun. We'll get some stuff actually implemented, and maybe we'll build a little token issuance and management interface so that people can create tokens and have them tracked on overlays, and then facilitate the sort of exchange of those tokens between parties and their use in various contexts. So yep, that's it for me. Tune in next time. I do look forward to it. This is going to be fairly useful, I think. Like I said, I didn't realize I was coding for the general case here, but sometimes that's just the way it goes. So, thanks for watching, folks. Bye-bye.